Now we are going to learn statistical methods, measures of central tendency and dispersal, like mean, raw data, discrete series and continuous series, standard deviation, standard error, degree of freedom, raw data, discrete series and continuous series, quartile deviation, and box whisker plot. So let's start by having a quick introduction. In statistical analysis, measures of central tendency and dispersion are important tools to describe the characteristics of a dataset. In this essay, we will discuss in detail the measures of central tendency and dispersion. Measures of central tendency. Measures of central tendency are used to describe the central value of a dataset. There are three types of measures of central tendency. Mean. The mean is the arithmetic average of the dataset. It is calculated by adding up all the values in the dataset and dividing by the number of values. Next, median. The median is the middle value of the dataset when the values are arranged in order. If there is an even number of values, then median is the average of the two middle values. Median is the average of the two middle values. Mode. The mode is the value that occurs most frequently in the dataset. The mean is the most commonly used measure of central tendency. However, if the dataset contains extreme values or outliers, the median may be a better measure of central tendency as it is less affected by outliers. Measure of dispersion. Measures of dispersion are used to describe the spread of a dataset. There are three types of measures of dispersion. Range. The range is the difference between the highest and lowest values in the dataset. Next, variance. The variance measures how far each value in the dataset is from the mean. The variance measures how far each value in the dataset is from the mean. It is calculated by taking the sum of the squared differences between each value and the mean and then dividing by the number of values. Standard deviation. The standard deviation is the square root of the variance. It measures the average distance of each value from the mean. The standard deviation is the most commonly used measure of dispersion. It is useful in determining the spread of the dataset as well as identifying outliers. A larger standard deviation indicates a larger spread of the data, while a smaller standard deviation indicates a smaller spread of the data. Suppose we have a dataset of heights of a sample of individuals. We can calculate the measure of central tendencies and dispersion to describe the characteristics of the dataset. The mean height can be calculated by adding up all the values and dividing by the number of values. The median height can be found by arranging the values in order and finding the middle value. The mode height is the value that repeats most frequently. To calculate the range, we find the difference between the highest and lowest values. The variance can be calculated by taking the sum of the squared differences between each value and the mean and dividing by the number of values. The standard deviation is the square root of the variance. In conclusion, measures of central tendency and dispersion are important tools in statistical analysis. They provide a summary of the dataset and help to understand the characteristics of the data. The choice of measure depends on the nature of the data and the purpose of analysis. Next, mean. Mean is a measurement of central tendency used to describe the average of a dataset. There are different methods of calculating the mean depending on the type of data. In this essay, we will be discussing how to calculate the mean for raw data, discrete series and continuous series. So first, mean for raw data. Raw data refers to a set of individual values. To calculate the mean of a raw data, we need to add up all the values and divide by the number of values in the dataset. For example, suppose we have a dataset of weights of 6 people. To calculate the mean height, we add up all the weights and divide by the number of people. And we just get the mean value of weight. Mean for discrete series. Discrete series refers to a set of values that can only take on certain values such as integers. To calculate the mean for discrete series, we find to multiply each value by its frequency and up the products and divide by the total frequency. For example, suppose we have a dataset of a number of books read by a group of students. To calculate the mean number of books read, we multiply each value by its frequency, add up the products and divide by the total frequency. Continuous series refers to a set of values that can take on any value within a range. To calculate the mean for continuous series, we need to find the midpoint of each class interval, multiply it by its frequency and add up the products and divide by the total frequency. To calculate the mean height, we need to find the midpoint of each class interval and just multiply that midpoint by its frequency, add up the products and divide by the total frequency. In conclusion, the calculation of mean depends upon the type of data. For raw data, we add up all the values and divide by the number of values. For discrete series, we multiply each value by its frequency and up the product and divide by the total frequency. For continuous series, we find the midpoint of each class interval, multiplying it by its frequency and up the products and divide by the total frequency. Now let's learn how to calculate the standard deviation. Standard deviation is a measure of the variability or spread. Standard deviation is a measure of the variability or spread of a data set. It tells us how much of the values in a data set are spread out from the mean or average value. Calculating standard deviation involves several steps. Calculate the mean of the data set. For each value in the data set, subtract the mean from the value to get the deviation. Square each deviation value, add up all the squared deviation values, divide the sum of squared deviations by the total number of values in the data set minus 1. Take the square root of the result from step 5 to get the standard deviation. Here an example illustrate how to calculate standard deviation. Let's say we have the following data. Calculate the mean first, and after that calculate the deviation for each value in the data set, and after that add up all the square deviation values. Square each deviation value before that and then add up all the square deviation values. Later divide the sum of square deviations by the total number of values minus 1. Minus 1 because it's a raw data. And then we just take the square root of the result from the previous step to get the standard deviation. Therefore, the standard deviation of the data set is approximately 1.58. This tells us that the values in the data set are relatively close to the mean with only a moderate amount of variability. Standard deviation is a statistical measure used to quantify the amount of dispersion or variability in a set of data. It is a measure of the spread of data around the mean value. When dealing with a discrete series of data which consists of a finite set of values with no immediate values, the formula for calculating the standard deviation is slightly different from that used for a continuous series of data. To calculate the standard deviation of a discrete series of data, you can use the following formula. S is equal to square root of summation x minus x bar square by n minus 1. Where s is the standard deviation, x is the value in the data set, x bar is the mean value of the data set, and n is the total number of values in the data set. Here is an example. We just got the data set. Later that calculate the mean, and after that calculate the deviation for each value in the data set. Square those deviations. Later add them and divide the sum of square deviations by the total number of values. Take the square root of the result from step 5 and get the standard deviation. If the data is raw score data, we will be just dividing it by the total number of values minus 1. This tells us that the score is spread out from the mean by value by 82 by approximately 9.89 points. The larger the deviation, standard deviation, the more spread out the data is. The larger the standard deviation, the more spread out the data is. The smaller the standard deviation, the more clustered the data is around the mean value. Standard deviation in case of continuous series. In statistics, continuous series of data is one in which the values are not restricted to a specific set of discrete values, but rather can take on a value within a range. For example, the height of a group of people or the weight of a sample of products are continuous variables. To calculate the standard deviation of a continuous series of data, you can use the following formula. Where S is the standard deviation, x is the value, and the procedure is same as that which we have mentioned earlier. However, in the case of continuous data, the formula becomes more complex since the range of possible values is finite. Therefore, instead of calculating the standard deviation for each individual value, we need to calculate the area under the curve of the probability density function of the distribution. One common example of a continuous distribution is the normal distribution. The normal distribution is a bell-shaped curve that describes the probability of occurrences of a random variable. It is characterized by two parameters, the mean and the one standard deviation, sigma. Mean mu and standard deviation, sigma. The formula for the standard deviation of a normal distribution is square root of x minus mu square by n, where s is the standard deviation, sigma is the population standard deviation, x is the value in the data set, mu is the mean value of the data set, and n is the total number of values in the data set. First, we just take the mean. We have the mean. Standard deviation is there. Identify the mean and the standard deviation of the data set. Use the formula to calculate the standard deviation. Standard deviation of the data set is equal to the population standard deviation, which is 10. This means that the height of the people in the data set is relatively tightly clustered and the mean value of 170 centimeter. After that, we will be calculating the standard deviation for continuous series of data involving probability density function of the distribution and calculating the area under the curve. For a normal distribution, the formula is simplified as shown above, but for other types of distribution, more complex calculations may be required. Next is the calculation of standard error. Standard error is a statistical measure. Standard error is a statistical measure that indicates the variability of a sample mean estimate from a true population mean. It is easy to estimate the precision of a sample mean as an estimate of the true population mean. The formula for calculating the standard error depends on the type of data you have. Standard error for raw data. When you have raw data, the standard error can be calculated using the following formula: SE is equal to S by square root of N. Whereas E is the standard error, S is the sample standard deviation. So, SE standard error is equal to S by square root of N, where S is equal to population ST. For example, suppose you have a sample of 10 test scores. The sample mean is given and the sample standard deviation is also given. The standard error can be calculated as SE is equal to standard deviation by square root of N. In case of standard error for discrete series, we get the information of this particular formula like SE is equal to square root of summation f into x minus x bar square by n minus 1 square root of n. So we will be applying that. First sample is there, sample mean is also there, like square root of summation f into x minus x bar square by n minus 1 whole square all by square root of n. Therefore, the standard error of the sample is given. Standard error for continuous series. If you have continuous series data, the standard error formula is SE is equal to S by square root of n, where S is equal to standard deviation. N is the sample size. The standard error is a useful statistic for estimating the precision of a sample mean as an estimate for the true population mean. The formula for calculating the standard error depends on the type of data you have, raw data, discrete series or continuous series. So what is the meaning of the standard error? Standard error is a statistical method that indicates the variability of a sample mean estimate from the true population mean. Next topic is degree of freedom. Degrees of freedom is a concept used in statistics to describe the number of independent pieces of information in a sample or data set. It is a crucial concept when calculating statistical tests such as t-test, chi-square tests and ANOVA. The degree of freedom depends on the type of data you have, your raw data, discrete series or continuous series. Degree of freedom for raw data, when you have a raw data, the degree of freedom can be calculated as df is equal to n minus 1, where df is equal to degree of freedom and n is the sample size. we can see that the raw data is given. So we will be calculating the df is equal to n minus 1. Degree of freedom of the sample is 9. And then in case of discrete series, df is equal to n minus k, where df is equal to degree of freedom and n is the sample size, k is the number of distinct values in the sample. When you have a continuous series, the degrees of freedom can be calculated as k is equal to 8 in the previous example. Sample of 20 heights and 8 particular. So k is equal to 8 and n is equal to 20 and df is equal to n minus k. In case of continuous series, we just apply the formula used for raw data like n minus 1. In summary, the degree of freedom is a crucial concept in statistics used to calculate statistical tests such as t-tests, chi-square tests, and ANOVA. The degree of freedom depends on the type of data you have, raw data, discrete series, or continuous series. The formulas for calculating the degree of freedom each type of data is different and should be used accordingly. Next is the quartile deviation and box plot. Quartile deviation and box and whisker plots are two tools commonly used in statistics to visualize and analyze data sets. In this essay, we will discuss these tools, how they are used. Firstly, the quartile deviation is a measure of dispersion that indicates how spread out a data set is by measuring the distance between the first and third quartiles. The first quartile is the value below which 25% of the data falls, while the third quartile is the value below which 75% of the data falls, and quartile deviation is calculated as the half the difference between Q3 and Q1. Q3 minus Q1 divided by 2. For example, let's consider a data set of 10 values. The first quartile is 3. The first quartile is 3. Third quartile is 8 and the quartile deviation is 8 minus 3 by 2. Q1 minus Q3 minus Q1 by 2. Quartile deviation is equal to Q3 minus Q1 by 2. So we will be calculating it accordingly. First we need to arrange the data from higher to lower, and then we just calculate the quartile deviation by dividing Q3 minus Q1 value by 2. The box and whisker plot is a graphical representation of a data set that displays the quartiles, quartile deviation, and outliers, if any. The plot consists of a box that represents the middle 50% of data with a vertical line inside the box that represents the median. The whiskers extend from the box to the smallest and largest values that are not considered outliers. Outliers are represented as individual data points outside the whiskers. Let us see some data set as about to construct a box and whisker plot. First, we need to calculate the quartiles and quartile deviation, which we already did. The box will extend from Q1 to Q3, which are 3 and 8. The median is 5.5, which falls in the middle of the box. The whiskers will extend from 1 to 2.5 and from 8.5 to 10. These values are beyond the quartiles and quartile deviation and therefore considered outliers. The importance of quartile deviation and box and whisker plot lies in their ability to summarize and communicate key features of a dataset, such as its central tendency, dispersion, and outliers. By visualizing data in this way, it is easier to identify patterns, trends, and anomalies that may be important for decision making. Additionally, these tools provide a standardized way to compare multiple datasets and draw meaningful conclusions from them. The quartile deviation and box and whisker plot are important tools in statistics for summarizing and visualizing data. The quartile deviation measures dispersion, while the box and whisker plot displays the quartiles, quartile deviation, and outliers. These tools can help to identify patterns, trends, and anomalies in datasets and make informed decisions based on them.